Hey everyone, I have a great little trick for you that will drastically reduce the amount of soldering you have to do while you're tinkering with your Raspberry Pi, Arduino, or whatever other tech mischief you might find yourself involved in. I'm not a huge fan of soldering. On top of that, I have a condition that causes my hands to shake sometimes, so soldering tiny little components together can be challenging for me. These little L-shaped pin headers I'm about to show you are part of my solution. Here we can do just a little bit of soldering to make these pins, and it will save us a whole lot of soldering later. And as you can see, it's going to make for just a nice little slide into the breadboard there. Easy to connect all of our other componentry right there to that set of pins. You've probably seen these. I love these little solderless breadboards for my Raspberry Pi projects because even with shaky hands, they allow me to still tinker like I love to do. And you can pick these up pretty cheap on Amazon. It makes it really easy to switch parts out if you change the design or if you just make a mistake. And for the most part, they hold things in even at odd angles. You can see here that I've got this part flatter, in fact, than this 3mm LED, so it's going to go really nicely onto the board for a situation like this where you want to cover up those components a little bit more, make it a little neater. I've obviously left our ultrasonic sensor showing just because I think they look really cool. One major drawback to these boards, though, is that they really only can be accessed from the top. This means you inevitably have wires sticking out all over the place, which is a real nuisance, especially when you have parts that need to sit close to the board like buttons or LEDs, which is why it's important that we have these pins sitting nice and close to the board. For example, I work from home, so I have this little guy set up to tell people outside of my door if they can come in or not. I push a button, and the light comes on outside my door that matches what I see here. The problem is I have to be careful not to bump the wires or anything as I try and push the buttons, and I can't really like reach over from the back or I get those wires. That being said, let's talk about how we solve the problem. Making an L-shaped set of pins that serves as a hub for all the connections on your board can rein things in and make them much tidier. On top of that, it allows you to cover the majority of the board with some kind of protection or aesthetic improvement while still allowing close to the board components to show through without being super awkward. Here's what you'll need. You want some pins. How many is really up to you, but however many connections you're trying to make, you'll need twice as many pins. So in today's example, I'm going to make an L-shaped connector with 10 connections, so I will need a total of 20 pins because as you can see here, oh, come here. We have pins that go down into the breadboard as well as the ones that protrude out that our jumper wires will connect to. Plus, I'll want just a few spare pins that we can stick in the board to prop up our pins that we're going to solder. I'll talk about that in a minute. If you need to cut or separate your pins, you'll need a hacksaw, some pliers, and a vice grip. You'll also just need a soldering iron, a solderless breadboard, and then of course some solder and flux. If you've worked with a Raspberry Pi or other SBC before, you've likely worked with these or something similar. This is the pin header that you would put into a Raspberry Pi to gain access to the GPIOs. I have a bunch of these laying around, so this will do just perfectly for the pins that I need. Like I say, I need 2 sets of 10 pins, but the way these pins are naturally divided makes that difficult. They can be snapped the short way into groups of 2, but if I go through and do that, I'll have to put a bunch of pieces back together, and I don't really want to do that. So I'm going to take a little different approach. I'm actually just going to cut right down the center of our strip here. I'm going to start by placing the pins firmly in the vice grip, tight enough that they don't move, but I want to be able to get a hacksaw through them so they can't be totally squished. I'm going to count and double count the pins to make sure I'm snapping off the right amount. These pieces snap off easily once I can figure out how to position my pliers. Then I'll position the hacksaw and run the blade down gently so that the teeth bite in. After that, it's just a matter of being patient with the saw as you go through. It sounds obvious, but try to make the cut as straight as possible. You'd be surprised how tricky that can be. Either side has plastic that's too thin, the pins will come loose and fall out. I'm going to go ahead and repeat this process with the other set of pins that I snapped off. There. Once we have our two separate pieces, it's time to get out the soldering iron. Now what I've done here is just stick a couple sets of pins into a breadboard long side down. I'm holding the other set that we're going to solder. We're just going to line up the short end of the piece I'm holding with the other short end on the breadboard. We'll set it in place such that the set of pins closest to me will be soldered together. The set of pins stuck in the breadboard that is farthest from me will just be used as a prop to keep the pins nice and level. Now I'll go ahead and apply flux. I use my hot air soldering wand to heat the flux up to make it flow, but even just having the flux slightly above room temperature should be sufficient to spread it. Don't be shy when it comes to the flux. We want our solder to flow nicely between our two contact points, and the last thing we need is to have to go back and apply more flux. Now you'll see what I mean about shaky hands. Getting the first tack in place is the key. After that, the rest is just making sure you don't miss. Oh yeah, it helps if you actually do something to hold your work still as well. Once we've worked our way through all the pins, we should just be able to wiggle our L-shaped masterpiece up out of the board. And there you have it. This little guy is going to make our life so much easier. Now you're done. You can put your soldering iron away. As you can see here, that is going to work wonderfully for our project. Yes, I know I have some wire spaghetti happening, but that will all be fixed once we put a case on. If you haven't hit that like or subscribe button, now's a great time to do so. Connecting to the board after that is a breeze. The one caveat here is to make sure that you draw a diagram or label your pins in some way. If you don't do that, you'll likely forget which pins are which, and you'll find yourself tearing the thing apart to reverse engineer it if you have to perform maintenance for any reason. So yes, diagram or label your pins. So hopefully doing this little bit of soldering right now will save you a lot of soldering in the future and hopefully a lot of frustration as well. Thanks for watching. Feel free to drop me a comment if you have any questions or if there's something else you want to see. See you next time.